All right, so now we're just going to add word problems to this whole right triangle trig, which is really not more difficult. Don't freak out. Just take your time reading them. Be careful sometimes, because sometimes they might be talking about the hypotenuse, or maybe this distance you are from the tree is the ground there. Don't think of it as that wouldn't be the hypotenuse. So just read it carefully and make sure you figure out what are the sides that they're talking about. That's usually where the mistakes are made. I mean, obviously, in this case, opposite would be the height of the tree. Then the distance to the top of the tree to the person would be the hypotenuse. And then the distance from the person to the tree would be the adjacent side here. Now, angle of elevation is commonly used as well. That's the angle created from the ground looking up to the top of the object. So that's just going to be that angle there. So you got to get used to these terms. Really don't overcomplicate it. Pretty simple to do these if you got the other lessons. So right here, Galileo wanted to release a wooden ball and an iron ball from the height of 100 meters and measure the duration of their fall. He found a plane with an incline of 12 degrees that he could climb until he got to an altitude of 100. How far should Galileo walk up the inclined plane? So if this is the plane, this is like kind of like, a hill here. He's not going to walk through the hill on the floor. So obviously, if you see this triangle, what they're asking for here, the unknown, is going to be the hypotenuse. This would be your triangle. This would be the 90-degree angle if you were to draw your triangle, right? So we're going to use the 100 for this side. We have a 12-degree angle, and we're going to find the hypotenuse. So we have opposite, and hypotenuse is going to be sine. If you remember SOHCAHTOA, opposite and hypotenuse is sine. So sine of 12 equals the opposite, which is 100, over x. So x equals 100 over sine of 12. Make sure you're in degrees. We're just going to pop that right into the calculator. And I'm not in degrees, obviously, because I got a negative answer. And that's going to be 400, and let's see what they wanted. Round to the nearest hundredth meters. So 480.97. And there you go. Right here, I'll just kind of label the sides or show you which one we're looking for. So how far from the skydiving center did Stella land? So if you read this, Stella's friends got her a skydiving lesson for her birthday. Her helicopter took off from the skydiving center, ascending at an angle of 37 degrees and traveled distance of 2.1 kilometers. So this would be the skydiving center right here. So you have to pay attention to that. See, a lot of people are thinking like, how far was she or how high up was she? If I was asking that, they would want this opposite side. But here's the skydiving center that I poorly drew. Let me actually erase it. So they want to know what is this distance here. How far, once she landed, how far from the skydiving center was she? Okay, this last one's typically the one that people get confused by, so I'm going to do this one. This one's kind of straightforward, so let me do this one. Howard's designing a chair swinging ride. The swing ropes are 5 meters long, and in full swing, they tilt at an angle of 29 degrees. Howard wants the chairs to be 2.75 meters above the ground in full swing. How tall should the pole of the swing ride be? So what we're looking for is this length right here. We want to figure out how tall is this pole going to be. I should put that right here, actually. So that's what we're looking for, that total thing. But let's go ahead and draw our triangle. So our triangle is actually going to be this part here. And so we don't need, if this is our reference angle, we don't need the opposite side. We want to know what is this side. We know that this measure from here to here is 2.75. We know that. But we need to find what is this given the triangle. So we have a reference angle of 29. We want the adjacent side. I don't know why I pick red. You can't see it there. We want the adjacent side, and we have the hypotenuse. So if you go through SOHCAHTOA, that would be cosine. So cosine of 29 equals x, because that's what we don't know, over the hypotenuse is 5. So x equals 5 cosine of 29. I'm going to go ahead and just enter that real quick in the calculator to get 4.37. They want the nearest hundredth, so there you go. So that's going to be this height here. That's our adjacent side. 4.37 is for that height. And then we know the rest of it's 2.75. So I'm just going to take that and add it to the 2.75. To get 7.12. And that's going to be our final answer. And there you have it.